All right, buongiorno everyone, welcome. So first of all, who here is from Verona, Verona? Not so many. So this title picture is for you, hope you recognize it. And now for everybody else, let's talk about automated Angular architecture validation with ESLINT. So probably most of us working in software development have this experience. You start working on a new project, you know, you have your architecture, you have your design doc, and you start working with your colleagues and it goes just great, right? You are working on a green field, everything is clean, you can ship features fast, it's really fun, you are looking forward to coming to office and ship another great feature for your users. It's just fun to work with. And I think like most of us, or I hope for you, that all of you experience this nice pristine code base where everything goes right. But for sure, what all of us experienced was if you have a older, let's say, mature code base, right, where some things already made it there which probably should not have made there in the first place, right? So it kind of feels a bit like going through a swamp. The speed is not as good, like you feel a bit like dirty, like you have to touch some features. But again, you know, it is what happens, and especially like in a year, 2, 4, or 5 of development on a project, this is which tends to happen. And if we bring it bit more into like a, you know, reality or the code space, what tends to happen is that we start like with a very nice clean dependency graph between, you know, the features and the files in our source, where it's obvious, like it goes nice left to right, it looks very organized. And over time, it tends to degrade into something a bit more chaotic, right? And we already have there like some red and some circular dependencies. And you may or may not believe it, but this picture is actually from a real code base of one of the customers where we analyzed like their project, and you almost don't see files. It's just like a crazy web of dependencies between the files. It looks like some kind of, you know, spider came back from a party and started throwing features around. And this is actually real. And, you know, at this point, you are in a situation where you probably cannot really save this anymore, right? So we would probably like to learn how to stay as long as possible or even forever here and never really progress there, because that would be best for everyone involved in the situation, right? But first, let me quickly introduce myself. So my name is Tomas Trajan, and I'm a Google developer expert for Angular, and I like to say that I build, teach, write, and speak with and about Angular. So build angularexperts.io, you can check like the services which we provide for the companies worldwide, you know, consultancy, anything you might need. Teach workshops with focus on Angular, RxJS, NgRx, and NX. Write, check out our new free blog at angularexperts.io/blog, and speak at various conferences. This is the Verona, around the world, and meetups. Perfect. So let's get to the actual topic. So why architecture matters? Well, clean architecture has a lot of positive benefits, of course, and it's very important to realize that it's for everyone involved. So, of course, it's like for us as a developers, right? Because that way, you know, it's like the more maintainable code, you can spend less time like fighting with your code base and more time, you know, shipping features. It's easier to extend. So it's for the developers, but it's also for the users, right? Because then the performance tends to be better. Is it okay? Hopefully. The performance of the application tends to be better if it's clean, right? And it's also better for the company itself, because that way the company can react to the changes at the market and deliver cool stuff for their users faster. So it's literally like win, 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 win. Everybody wins if we have a clean architecture, right? So for user, faster startup time. For the developers, if it's clean, if it's separated into fully independent, like lazy features, then also the rebuilds and the retests tends to be faster. So it's very cool. And last but not least, what is sometimes overlooked is that if we have a clean architecture, we get something which can be named like isolation guarantees. So what does that mean is if we have a large code base and we have like 20 features, right, like 20 pages or whatever, however you want to call it, if we are guaranteed that they are fully isolated from each other, then what that means is that if we are making a change in one of those features, we do not really need to understand the other 19 features because we are guaranteed that we could not have had any impact on the rest of the code base, right? So it's much easier to perform something because I don't have to spend now like 3 days looking throughout all the like weird paths through the dependency graph of what are all the things which I'm affecting. So that means also we will probably introduce much less regressions, much less bugs, just overall better situation. So the isolation guarantees are one of the things which is not really talked about a lot, but it's one of the most important positive outcomes of a clean architecture. So and how this can be like visualized, so this is a bit older, right? We have still like modules here, but doesn't really matter. So basically every Angular application has these two main parts, right? The eager, which is available from start, and then the lazy. And I think like many applications in the wild embrace something like this, that we have, the core application-wide infrastructure with like the logger and the configuration service and the authentication service and all this kind of stuff, which is available in the whole application, right? And then usually what we strived for is to have the actual business feature as the lazy loaded features. And again, this is a bit older, but it's more like just to set the stage, right? And then usually in practice in the source code would look something like this, right? We have source up, and then we have core, and then we have features, and maybe some kind of shared for the shared widgets, right? But the problem with this is that without automated architecture validation, this is just like a hope-based architecture, because we are basically just hoping that everybody will pay attention 100% of time at every single code review for like 5 years straight, also when the senior goes for holidays, and it just doesn't really happen. It's just not realistic to expect that everybody will be fully focused 100% of time. So what tends to happen over time is that the dependencies which we never wanted to have in our application slowly creep into our code base, right? So it's probably really safe to say that the eager part should never really consume anything from the lazy part, because that breaks the lazy loading, right? It breaks the one-way dependency graph. Also, between the features, usually you want to have them as isolated as possible, so you probably want to prevent that one lazy feature consumes something from the other. There are better ways to solve it. You can always pull one level up, right? So if the two lazy features need to use the same component or same widget, you can put it up to the shared or to UI or something like that. But this tends to happen in a practice, right? So the hope-based architecture outcomes are that it's great, but folders will look correct, right? We have like some core and features and UI, but actually behind the scenes, we slowly over time start to introduce coupling, which we never wanted to do in the first place. So we break the one-way dependency graph, and this will have definitely negative impact on maintainability and extendability, and therefore our development velocity over time. So kind of everybody starts to lose. And if we try to validate this manually, which we actually did in day-to-day business before we realized how we can do it automatically, is you would click on a feature, and then you would, in your editor, you would try to search like .. and go through all the other names of every other feature to see if by any chance you introduce this kind of import. And this is just not really scalable process. So the question is, can we do better? And that's like without hiring 3 additional colleagues who will just focus 100% on validation of the dependency graph. So what if we can get something like this? What if we had like a out service? So that's something which most likely is in a core, in an eager part, right? Which is like authentication state for the whole application. And if we try to import a service from a lazy feature, which is never okay, what if we could get like a violation directly in our editor, which would say like, oh, actually you are trying to import feature from the core, and this is never okay. So we would get this kind of violation directly in our editor, and of course, also in like our CI environment when we make a merge request. So I think that would be really cool, because it would prevent us from introducing this kind of incorrect dependencies in our code base, right? So, and this can be achieved with ESLINT in standard Angular CLI workspaces. So let's learn about that. So the cool thing about this is that most Angular projects already have ESLint, right? And even if you don't have it, you just run NgLint and the Angular schematics will add it for you immediately automatically. So it's very easy to get started with, right? So, and we can validate our architecture in our editor and of course in our CI environment for every merge request, for every pull request. So therefore we do not need to depend on the hope, and we can prevent all these undesirable imports which really in practice tend to happen, and preserve the isolation. So there was this one code which I liked and sets the stage for the next step. So basically software architecture is the art of drawing lines that I call boundaries, and these boundaries separate software elements from one another and restrict those on one side from knowing or affecting the others, and that's literally what we want to achieve. And that's why it's great that ESLint actually has this thing called ESLint plugin boundaries. So who here heard or used this plugin ever? One person. So 2 people. So great. So then you will learn something today. That's perfect. So it's pretty easy to get started with, as we will see, and it works with basically folder structure and convention. So that means it can work also in a standard Angular CLI workspace, so you don't need something like NX. You can get started with like a most standard Angular setup. And the huge advantage of that is that there is actually no overhead. You do not really need to change your source code in any way besides following that convention, and this architecture validation system lives in ESLint config, so there is zero overhead in your actual source code. You don't have to like provide anything special in your folders, which is really nice. So, and there are 2 main systems of how this works. We have to define the architectural types. So this can be, you know, like a core or feature. So whatever you want to do, you can make like your own vocabulary of your architecture. Most likely with Angular, you will have like lazy features. You will have most likely some kind of shared UI widget, right? You will have probably some kind of core infrastructure. And then the second part or the second system is that we are allowed to define like the relationships between those types, right? So we will see that very quickly in the minimalistic example, which will illustrate how this works. So then you can take it and make it your own in your application in the way that makes systems for your specific use case. Because of course, there could be like some prescribed way, but most likely there is like so many different applications that you will come up with your own way how to structure this, which suits your needs. So let's start with something which most likely makes sense for all of us here. So every Angular application has these 2 main parts. We have the eager part, which is there from start, right? So this will be some kind of like core infrastructure, as we said, loggers, configuration service, authentication service, maybe some layouts. So all these things which need to be there from start, and all these things which are usually available to the rest of the application. So we have this core, right? And it's usually headless. And then we will have the feature type, which is kind of like the opposite of that. It will be lazy loaded. When you navigate to some page, right, you can go to dashboard, you can go to product list, whatever you have. And this is lazy loaded, right? So already we see there will be some kind of relationship between them. So there will be business logic, components, and all this kind of stuff. Perfect. So now, what could be like the rules based on what we discussed until now, right? So the 2 things which we want to focus on is to preserve one-way dependency graph, especially in relation to like the eager part should never consume from the lazy part, but the other way around is okay, right? So, and the other one is isolation between the sibling lazy features. So then we can say like that the core can never really depend on feature because core is eager and the feature is lazy, but the other way around is completely fine. So the feature can import like logger from the core, or the feature can import the configuration from the core. This is desired. And we can say that the features cannot really depend on each other. They are separate. And if we want to share logic, we have to do it differently. We have to do it in a clean way. But we want to preserve the isolation between those features. So this is like the description, or how it would look like in a more visual way. We can have a diagram, right? So we have this eager lazy part, eager lazy boundary. And here we have a core. And we say that the features are allowed to depend on the core, but core is not allowed to depend on the feature, and the features cannot really depend on each other. Perfect. So how can we implement such a very most simple architecture with this automated architecture validation with ESLint? So first of all, we have to install this plugin. This will not be available out of the box. If you do NgLint, you just get the ESLint, but you do not get the plugin boundaries. So we have to get the plugin boundaries, and we also have to get like this ESLint import resolver TypeScript. It's just some kind of like, helper library which allows this plugin to recognize the TypeScript dynamic imports which Angular uses to basically in the route config to do the lazy loading, right? So that's just some kind of boilerplate. And then in our root ESLint RxJS, we will again add some kind of boilerplate configuration, which you also can find, of course, like in the documentation on the GitHub or NPM. It's just like this standard thing which we have to add to be able to start using it. So for the TypeScript files, we add the plugin boundaries, so it just enables it, and then we add some settings, and it's like import resolver for the TypeScript. Again, you don't really have to care about this, just good to know that this is necessary for it to recognize the Angular lazy features, and you will find this in the documentation, some kind of boilerplate. Okay, and then we can also add like a preset. So for example, plugin boundaries strict. So, and this is will be like a topic of the strictness, which we'll discuss more in depth like at the end. But basically what this means is that every single file in our source has to belong to some kind of architectural type. This can be great for the new applications, but for existing application, probably too strict to start with because we had too many violations. Right, so with this, we already can start using our plugin. So that means it's fully configured. And now the next step will be to start defining these architectural types. So, and we want to define two types, right? The core and the feature. So then again, like in the root ESLint RxJS for the TypeScript files, in the settings, we want to start specifying the boundaries elements. So first type is core, and we say the type core will be everything which will have the core keyword in its file path. So that's like some kind of convention. So how would that look like? We have source up core out service. We have source up core user, whatever, configuration service. So, and with this kind of configuration, the ESLint will recognize that those two things belong to the type core because the core was in the file path. So it's like this kind of convention-based approach, and therefore there is no overhead. You don't have to specify any kind of metadata in your source code. Of course, there is a limitation. If the core is like a reserved keyword, then if you would have like feature, dashboard, core, whatever, that would be a problem. But in my experience, this doesn't really happen too often, and there will be a relatively small amount of these reserved keywords. So therefore, it's not like a big deal, but it's good to be aware of that. Cool, so we have our core type. It will be recognized from the source based on that pattern core. So if the core keyword is available, is present in the file path, we are going to recognize it as a core type. And now for the feature, again, type feature. And whenever there was a feature in the file path, we will say it's a feature, but it's more than that because it's not just like one feature. We can have many lazy features, and we want to actually recognize them by name. So how does that work? Hopefully you can see here it's feature/star, and then whatever was in that star, which will be like the next folder, which will be basically the feature name, will be captured into the feature variable, which we can then also use later. So how does that look like? Source up feature order service, dashboard component, dashboard item component. So as you would expect, this is recognized as a feature type, but then that next part of the file path is recognized as a feature name. So it's like on that level of granularity. So as you can see, we can say like, okay, core is just core, but for the features, we can actually define like for each individual feature, and the name can be dynamic. Great. So they are now recognized. So that was the second step, right? We had the boilerplate. Now we have the type system, and the last thing which is missing is to set up the rules which will govern the relationship of what is allowed and what is not allowed, right? So And that is again done in this root ESLINT RxJSON, again for the TypeScript files, but there is this, like then it's actually the rules, boundaries, element types, and we say if it's a violation, then it's an error, and then we can start defining rules. And then we say, okay, in this kind of architecture, core can only import within itself, so it should not really depend on the features. Of course, in practice, you might have like more types, right? So there will be more rules, but just to keep it as minimalistic as possible. And then with the feature, we say feature can consume from the core, and this would actually work already. And then we also say like that the default is that if it was not allowed, then it's disallowed. And then that is again in the direction of that strictness, right? So you want to make it as strict as possible. And again, the same trade-off. If you have a new application, you probably want to start with like as strict as possible, but with the existing applications, until you clean it up, maybe you have to be a bit more lenient, and then slowly add the strictness once you cleaned up your dependency graph. So, and this would actually work, but let's make it more explicit, because that previous state was when we say like, okay, the feature can import from core, but we also wanted to say that the feature are not allowed to import from other features, right? And this implicitly would actually work, but let's make it explicit. So what we are going to say is that feature can import from core and also from within itself. So it has to be the feature with the same name. And this can be done in such a way that we extend that config, that we say like feature can import from feature as long as it was from the same features, because that feature name is stored in that feature variable, so we can actually enforce that. So as you can see, it's pretty powerful system with like a relatively not verbose way to specify these things. Great. So we have this, and once we have this, we actually already introduced like full-fledged automated architecture validation system into our code base. This is all that it takes. We have our first two types, and we can start cleaning up our dependency graph and make sure that the architecture which we envisioned in the beginning actually happens in practice as well. And the great thing is that it will just happen even if we are not paying attention, right? Because those things are never okay, so therefore it will not allow us to merge such a code into our code base, and it will force us to clean it up before we actually push it into the main branch. So, and in this example, we see like, again, out service, that's like something in a core. Order service comes from feature order. So then again, type core cannot really depend on the feature. And which feature? Well, the feature with the name order. So we can see like all these things in play here. So you get the violation. It's pretty easy to read, so it's immediately clear like what went wrong. And then if you would need to do something like this, then you would start thinking like, okay, why do I actually need this here? Like which part of that state in that service do I actually need? Can I split it apart so that only that part which is actually necessary in a core will come in a core and the rest stays in a feature, right? Like it gives you these ideas how to solve it in a clean way. Perfect. So, and of course, the another rule which we added was that the feature cannot depend on each other. So again, we have an order service from the order feature, and suddenly we try to use part like from the product service from the product feature. Again, we get a great violation which says the feature from the order tries to depend on a feature from the product, and this is forbidden. So again, to solve something like this, we would have to start thinking like, why do we actually need that? Which part of that state or that functionality is necessary? Can we split that service into two parts, and one which is like reusable for multiple features and one which is feature specific without? So therefore, then we will be like explicit about what is there to be shared and what is feature specific instead of just coupling features. So as you can see, this is a very early signal which makes sure that you do the right thing which you set out to do in the first place. Great. So what about a multi-project setup? So who here ever did more than one Angular application in a single Angular CLI workspace? Quite some people. Perfect. So this kind of automated validation can support this use case for you as well. So we start where we left off. So we have these two types, right? The core and the feature. And basically now the situation is that, of course, if we have application A and application B, we should probably not be allowed to get like authentication service from application A in a core of the application B. That would probably not really make sense, right? So we need to have a way to enforce that. And it turns out that this is actually very easy and it will be very repetitive. So the plugin allows us to set up something called like a base pattern, and we can also then capture the name of the application in the base capture. So in the Angular CLI workspace, usually all these applications and libraries will live in a projects folder, right? So there is like this convention out of the box standard from Angular CLI. So that means project/project name, which can be, you know, example app or mylib or whatever. And then usually then it's /source app or source lib. So we can extract that name here. And that's how it would look like. Is again, we have this path. So now it's not just source app, but it's project example app, source app score. And the other app, we see we recognize the core type, but now we are also recognizing the application. Perfect. So now that we have this, we also have to extend our rule set, right? Because the rules only say, okay, if I'm core, I can consume from core. Well, this is not really enough. And the way it will work is exactly the same as we already did for the feature, right? So we are able to access some variable and compare it. So we say, okay, core can consume from core as long as the value in that app variable is the same. So if it's from the same app. And the same we did also, we extended like that feature one, where we say like, okay, feature can consume from the feature as long as it's the same feature and from the same app. So as you can see, it's pretty straightforward and it's very extendable. If you had some kind of, you know, multi-level system with some kind of scopes or whatever you want, you can just create some kind of convention. And as long as you follow that, or if you have some domains or whatever you want, right? As long as you have some kind of convention which you follow, that system can recognize it, extract those paths which are convention into variables and use them in comparison. So it's a very nice extendable system. And as you see, like it's just a couple of lines of code. It's not like you have to spend like now 2 weeks to coming up with something. Actually, you can get started pretty fast. Very nice. So now the error message was also extended. So it's like, okay, core cannot consume from feature, but here it's also like from the example app. And here it's also example app, but if it would be another app, of course, that would be the same kind of violation. So you see like that error message is progressively extended with all these kind of variables which you have been adding until now. So it provides you like with the easy to understand and easy readable error messages which you immediately know what went wrong. Because sometimes errors, when they are cryptic, it's like, okay, it failed, but like why? Well, here we know immediately why. Just that highlighting is missing, maybe that's something which they could add in the future. Great. So now, what about the libraries, right? So for all these people who already use these multi-project Angular repositories, you can have, you know, maybe 3-4 apps, and then maybe you add 2-3 libs, right? Because you want to share some logic between the applications. So as you would expect that this works exactly the same as until now, and again, there is no overhead. So we have to define additional type. So we had, you know, the core feature. Now we can add lib. And how do we recognize the libs? Well, if it's source lib and not source app, then it's a library. So we can recognize those libs, we can capture the name, and we can use it in our already existing rule system, which we had until now, where we say, okay, this is very simple. So basically anyone can consume from the lib. So, and of course, you can have like a generic lib type, but you can create like as many lib types as you want. You can create like the whole vocabulary of the things which make sense for your project. So again, very, very flexible approach. Great. So what about the strictness? So as we already discussed, there are these two main things. One is like this plugin boundary strict, which basically means that every single file has to belong to some architectural type. So in that case, what we did like until now, if we added this kind of strictness, this would of course fail because like the new Angular application has main.ts, appcomponent.ts, appconfig.ts, right? And all those files would then need to belong to some kind of type. So it would define like, okay, I have a main type, I have an app type, and they will be like very minimalistic. It's just to have everything covered. Or for example, like environment type, if you have environment files. So again, you will just add a couple of lines of config to cover those cases. And then you could enable these boundaries strict. And then a similar default disallow. So basically everything which was not explicitly allowed is disallowed, which I think is the safer way of doing things. So that way, if you look at that config, you have described everything that is allowed and what is possible within your code base. So like the main trade-off is like, yeah, if you do it in a new project, then please be strict from start. You will thank yourself later. You anyway describe some kind of architecture for a project, you know, in some kind of like diagram. So you can just encode this into those type systems, and then you can just completely forget about it and just mindlessly ship features, which maybe sounds like not so positive, but I find it like the most positive thing. I can just focus on delivering the features, the functionality, and I can completely forget about this topic because I'm guaranteed to make it right. So I think that's like a very cool state of like the doing things. I think it's like very similar to when you have like a prettier, right? So you can completely forget about the topic of formatting. It just happens. So the architecture can be very similar. Of course, then to resolve those problems, a bit more thinking than just like with the prettier, but still, right? You can completely forget about it. You are guaranteed to do the right thing. So, and of course, for existing projects, this can be enabled later once you clean up stuff. So, and therefore, like this previous example would fail because we had this and we didn't define the types for up or for end or for main. Okay. So the journey continues. Next steps, I think it's definitely worth it for you to explore this. We had a very good experience with this in a large enterprise environment with 220 spas and 30 libraries. So we had quite some like hands-on experience. So I can say with confidence that this works and it will be really good for you. So it's possible to add it gradually to your existing projects. Basically define two types, like some rule between them, clean up the violation, and repeat. Slowly keep adding types, slowly keep fixing the violations until you cover your whole code base. And once you have it, then you can enable the strictness. All right. And what to aim for, like this is again very important. Basically, we only shown here like how it's done, right? We had two simple types. We had the core, we had the feature. But now, like, okay, should we do like 30 types? Should we do like 5 types? What is actually reasonable? And I think this will be individual for every single one of you because no two projects are the same. But I think there are some kind of like general recommendations which will probably apply to you all. So basically, we want to definitely prevent this, and it's not like that it's not tasty, but the situation is that if you have a code base and you end up in a situation where whatever you pull, it feels like pulling the whole code base, then probably that's too little rules, right? Because that means that there was just too many tangled dependencies. And we had this actually also we've seen this in practice where there was some kind of library with components and we were supposed to modernize it, and then we realized like it was like really insane, like wherever we pulled, so if it would be button, it would be overlay, which would be message. Somehow they managed to couple those things together, even though they sound like completely unrelated. So probably not enough, well, in that case there were no rules, but definitely not enough rules. So this can happen, right? But then this is also not good, right? So if you have too many rules, and if you have like, okay, I have my feature, but within the feature I have like 10 different sub rules within the feature, how I do like a container component, and then like view component, and like mix component, and then like mini feature service, like that's also probably not good. You don't really want to have a situation where again, like you feel like, okay, like it's clean, but I cannot really move. Like I cannot really get things done. Like that's definitely not something which would be desirable, and it would lead to a lot of frustration. They would be like, okay, I don't want to use this, let's comment this out, let's disable it, and let's forget about it. So for sure, this would not be the way. So what about something like this, right? And I think this is like realistic. So that also goes in line with what we've shown today, right? So you have a core, and you are guaranteed that like this eager, lazy boundary will be preserved, or like you have like, you know, feature A, B, C, and you are guaranteed that those features stay separated. But if feature inside of itself is, quick and dirty, that's fine. That's fine. You got things done, and it's not really impacting anybody else. So in theory, you could even just like delete it and write it from scratch because it's like much smaller part of the code base. It's not like that you are affecting everybody else. So I think what you should aim for is to have like this level of granularity, which allows you to get stuff done quick and dirty within like a single thing, but you are guaranteed that you are not compromising the long-term health of your code base by polluting everything else. So I think what we've shown today, like with the core and the like a feature type, it's in line with that, and like similar types like this would be something which you definitely could benefit from. Right, so and if you want to save time and not just figure all of this from scratch and skip to the best part, maybe you can be interested in like an ebook which I wrote recently, which is called Angular Enterprise Architecture, which comes up with the opinionated preset of architectural types and rules. Version 2.4 out now, uses Angular 18.1, standalone first. There is an example repository which you can use as a starter, more than 180 pages of content, and all 8 years of experience distilled. And if you get it, you get a lifetime access to all the future updates. So people from the community like Enea seem to like it. It uses standalone first architecture with some cool types like pattern, feature, UI, layout. This is how the content looks like, a lot of code examples, a lot of diagrams, how to resolve those conflicts, what to implement in each individual type. Yeah, many folks seems to like it, and if you get it from here, you can get extra 33% off if you use Angular Day 33 until end of November. So with that being said, thank you for your attention. I hope you enjoy learning about the Angular automated architecture validation and that you use it in your projects to stay clean. Thank you.
Thank you so much, Thomas. We have several questions for you.
Perfect.
Yeah. So I remind you that you just need to scan the QR code that you have in your badge, and you can write down your question. So the first one: what new patterns of sharing code between features or using two features in a third one emerged when you started to enforce boundaries and needed to fix the new errors?
Right, that's a great one. So of course, like this is a first natural question. If we isolate feature, everybody experience that we want to use the same component in more than one feature, the same service in more than one feature. And like the most generic way how to explain this is like this extract one level up rule, right? So if we are on the first level of lazy features, that means if we have a reusable component, for example, we have to first clean that component out so that it becomes generic, so that it doesn't have really any feature-specific logic. So for example, like a product item, right? It can have some feature-specific things in it, but we can clean it up a little bit that it only receives everything through the inputs and communicates through the outputs, and then we can extract it to like a type called, for example, UI, right? So that would be like a one level up. Similarly for the service, right? We can create some kind of domain type, which is independent from the feature, where we, like all the product stuff can go into such a type, but the point is like one level up the dependency tree. If we had like multiple levels of features, which is also normal, you have a feature and that feature has a sub-navigation, which has sub-feature. So again, like one level up means into parent feature. So usually like the way to go about it is to follow this extract one level up rule. Hope that helps.
Cool. Then, is this validation working with an X path? Example, my app core. Will this cause conflicts with the already existing boundaries validation from NX?
Right. So this was focusing on the Angular CLI workspaces which do not have the NX stuff, right? And in my personal view, like at least half of the benefit of using NX, and which what I like give a huge props to NX, is that they popularized this concept at all with NX plugin boundaries, right? So if you have NX, then you can use that one. But like a little trade-off is that with the NX, then there is a little bit of overhead where you actually have to tag those libraries. So you have to put like that, okay, it's a type this and scope that, or however you like to create like that vocabulary. But yeah, definitely this is possible in Nx. Like the way I learned about it was through Nx, and this was an effort how to bring it also to people who don't really have capacity to learn like and invest into Nx and make everything into a library, because there is some kind of overhead involved. And for like small to medium projects, especially nowadays with like Angular embracing the ES build, you don't really need that, right? Because the build is fast enough, test is fast enough. So then the only thing which was missing was the architecture validation. And now we've shown how you can get that with the plain Angular CLI workspace and with no overhead, because you do not need to like manage those tags in folders or anything like that. Perfect.
We have many other questions, but we don't have no much time. But you will be here the whole day, right?
Yes, please.
So you can
come and talk.
Yeah, exactly. So thanks again, Thomas. Please, a huge applause.